Hello family, my name is Des, and like always it's good to have you, and today we are going to learn and have fun like always. And today we're welcomed by Baby, and he obviously has some secrets that he is not sharing with us. He's lifting too many weights. Anyway, how you guys doing? I really like to connect with you and to get to hear from you guys. So today we are starting off combined science, and we are doing physics under combined science, and we're still doing motion, but today we want to look at mass and weight. So let's go, let's get it, let's go. Yeah, so the first thing that we want to do is we want to distinguish between mass and weight. Are those two terms different, or do they mean the same thing? Obviously they mean different things, right? Mass is different from weight, but sometimes when you talk about it like in just general, right, we usually use them interchangeably, and so sometimes it feels like it's the same thing. People don't really know, is it the same thing, is it different? People don't really know. But today we're going to demystify all of that and see what it really is the truth and what really is facts from fiction. Okay, so let's explore the difference between mass and weight. Let me get my laser pointer. Yeah, boy, we're here. So let's explore the difference between mass and weight. So let's talk about mass. So imagine you have a big box full of colorful building blocks, like something like this. A big box full of colorful building blocks. The number of blocks you have inside the box represents the mass of the box. So mass is like the amount of stuff in an object, right? The amount of matter in an object. So if you have a stone, we're saying how much matter is contained in that stone, right? We're talking about the amount of stuff in an object. That's what we are calling what? Mass. So mass of an object is the measure of the amount of matter that it contains. So you got from this example, right, that if you had all of these things put in this box, the weight of the box would be the amount of the building blocks that you have. So this is an example just to try to show you what mass is. Or if you have a stone, the amount of matter that is making up that stone is what we are calling mass. So mass of an object is the measure of the amount of matter that it contains. So mass does not change no matter where you are or what you're doing. The mass will remain the same, and we measure mass using units like grams, kilograms. For example, a bag of apples might weigh 2 kilograms. So I hope this was very clear. Now let's talk about weight. Now this is where you're going to see the difference. Now imagine you're holding the same box of building blocks in your hand. The force that is pulling the box towards the ground is called gravity, right? So gravity is the force that is pulling everything down, right? So on earth, gravity is the source of gravity on earth is the earth itself. So everything is pulled to the ground. That's what we're calling what? Gravity. So when you feel the box getting heavier, that's because of what? Of gravity, because gravity is pulling on that box, right? So weight depends on both mass and gravity. So if you're on earth, the weight of a box is how hard gravity is pulling it down. So the weight of an object is how hard gravity is pulling it down. Do you see the difference between mass? Mass is the amount of matter in an object, but weight is how hard gravity. It is the force of gravity that is acting on an object. It is how hard it is pulling that down. So the reason why it feels heavy when you're carrying it, because gravity is pulling it down and you're trying to keep it up. So, but then if you take that same box and you take it to the moon, where the gravity is weaker, that same box will feel much lighter. Why? Because weight is the force of gravity acting on an object. So if you go somewhere where there is less gravity, it means the weight will also be less, because the ground or the moon is not pulling as much as the earth pulls, because it's weaker. Its gravity is weaker than that of the earth. So we measure weight using a unit called Newton. It's like a special scale that tells us how heavy something is because of what? Gravity. So in general, weight is the force of gravity acting on an object, and it is measured in newtons. And how do you get, what is the formula to get weight? Weight is equals to mass times acceleration due to gravity. Weight is equals to mass times acceleration due to gravity. So the acceleration due to gravity, it is how hard the gravity is pulling that thing down. So the gravity at the moon is different from the gravity on Earth, right? So how hard it pulls it down, it would also determine the acceleration that it will fall with, how fast the speed will change and increase as the thing is falling. So if you drop something at the moon, maybe you are somehow you are like 100 meters from the ground on the moon, right? And you drop something, it will take more time than something that you're dropping on Earth, and you're 100 meters from the ground and you drop something. It will take more time. Why? It is because the Earth's acceleration due to gravity, or the force that it is putting on that object to come down, is higher. So we call that force gravity, or which then causes the acceleration due to gravity. So sometimes we can call it acceleration due to gravity, and we measure it in meters per second squared, or we can measure it in newtons per kg, with how many newtons of force, how much force is pulling that mass down. So I hope you have understood that our weight is equals to mass times the acceleration due to gravity, how hard the earth is pulling that mass down. Now let's look at another interesting term called inertia. Now I want you to think of a smooth car ride. Maybe you are in my favorite car, in a Maserati, right? If you close your eyes, it might even be very hard to tell if the car is moving or standing still, right? That's because it's like your body is moving with the car. And that's a property called inertia. So when the car stops suddenly, if you apply emergency brakes, that's why we need these seat belts, right? Because if you apply emergency brakes, your body will continue to want to do what it was doing. So that's why you jerk forward, right? Such that if you're not putting your seat belt, you might even be thrown outside the window in front. Why? Because your body wants to continue at that speed that it was moving with. Because when the car brakes, your body doesn't brake, right? It still continues with that level of speed. Or let me give you another example. When a car just immediately when it was resting, and it just all of a sudden takes off at a high speed, right? You jerk backwards. Why? Because your body wants to keep doing what it was doing, which was what? Resting. So inertia is the resistance of a body to change its state of rest or motion due to its mass. So inertia is caused by by the mass, right? It is the body resisting to change its state of, if it was moving, it wants to keep moving. If it was at rest, it wants to keep being at rest. So the greater the mass, the more the inertia. Mass resists change from rest to motion, or from motion to rest. Right? We've already talked about that. However, it is equally difficult to stop the motion of a heavy object than a lighter one. Right? So, because inertia depends on mass. So if you're trying to stop something that is heavy, it is difficult because the inertia will be higher. And if you're trying to stop something that is lighter, it is easier because the inertia is what? Is also low. Let's go. So let me just explain a little bit more on the issue of gravitational force. right? G, usually it's a small letter G, yeah? Right? So imagine you're playing with your toy car on a slide. I don't know if you guys play with toy cars now, but anyway, that's besides the point. So imagine you're playing with your toy car on a slide. When you let go of that car, right? Let's say this is a slide like this, right? And your toy car is here. If you let go of it, right, the car will slide down, right? Why? Because of gravity. So gravitational force, which is represented by the letter G, is like the invisible hand that pulls things towards the ground. It makes the toy car slide down. So scientists use the letter G to represent this force. Now let's talk about unit mass. Think of a tiny piece of metal, like a grain of sand. We call that a unit mass. It's like the smallest amount of stuff we can talk about. So when we measure gravitational force, scientists measure how strong gravity pulls on this tiny unit of mass. So they use two important units, which is the newtons per kilogram. This tells us how many newtons of force act on each kilogram of mass. So how much force is acting on a kg to pull it down. Or sometimes we can use the meters per second squared. This measures how fast things are accelerating due to gravity. Due to that force that is pulling it down, how fast they are accelerating, how fast they are falling down. So that's basically gravity. So let's do an example of a calculation. Let's say you drop a ball, maybe from, maybe it was in a hoop like this basketball, right? You drop it, it was here, and then you just let it go. You drop it. The gravitational force acting on it is approximately 9.8 newtons per kg on Earth. That's the force of gravity on Earth. This means that for every kg of mass, gravity pulls with a force of 9.8 newtons. That's what that means. So now, using our formula, weight is equals to mass times acceleration due to gravity, which is g. So weight is equals to 1 kg, right? Acceleration due to gravity is 9.8, so the weight will be 9.8 newtons, right? So weight is a force. Remember, weight is not mass. Weight is the force, which is the force of gravity that is acting on an object. So it's measured in newtons. So that weight will be 9.8 newtons. So this is the kind of the triangle that we use. Weight is equals to mass times acceleration due to gravity. So if you're given weight and mass and you don't know the acceleration due to gravity, you can say weight over mass, you get the acceleration due to gravity. Or if you're given the mass and if you're not given the mass but you want to find the mass, and you're given the weight and the gravity, you just say weight over gravity, then you get the mass. I hope this is sinking in. So you guys, at any point, if you want to pause the video and just let this thing sink in, please feel free to do so. Let's do another exam style question, right? An object is a mass of 4.5 kg. This baby is intimidating me. Why are you looking at me like that? Anyway, sorry. Let's go back. Calculate its weight on Earth, right? So acceleration due to gravity on Earth is approximately 9.8 meters per second squared. That's acceleration, right? So weight is equals to mass times gravity. So we're told that the mass is 4.5 kgs, and then the gravity is 9.8. So our weight will be 44 newtons. So this is the acceleration due to gravity. Remember, acceleration, it's calculated in the form, the answer will be in meters per second squared. That's the change of speed with time. So that's how you get the squared here. So the weight will be 44 newtons. So sometimes, for making questions simple, they might just say G, this is supposed to be a G, not a 9. G, which is gravity, is equals to 10 meters per second squared instead of 9.8, just to make your calculations easy. But the more accurate is 9.8. So you just use whatever your exam says you should use, but this is the more accurate one if you're not told anything.